Hello everyone. Welcome to the sixth session of MySQL database training. Till now, what all we have seen? We have seen the overview of MySQL, the database versions, the client server architecture of MySQL, the popular storage engines which were InnoDB and MyISM, the server logs, various type of server logs like relay log, binary logs, then general logs, MySQL socket file, InnoDB tablespaces, MySQL database schemas and the new features in MySQL 8. So these were the theoretical parts. In the practical sessions, we saw about how to install MySQL and how to configure the various logs, different types of ways of taking the backup using the MySQL dump backup utility. In this session, we'll be seeing on MySQL replication. So let us start with the theoretical part first and then let's jump to the practical session of MySQL replication. So to make MySQL totally reliable and available in cases of high load, database replication and clustering are the possible solution to achieve this. As MySQL is one of the first open source databases, its replication capabilities have evolved in time. So what is replication? Replication enables data from one MySQL database server, which is the master, to be replicated to one or more MySQL database servers, which are the slave. In here, we can see a master-slave replication is there. So you can use replication to solve a number of different problems, including problems with performance, supporting the backup of different databases, and as a part of larger solution to possibly remedy failures, system failures. This MySQL master server writes all the database changes to the binary log, or we also call it as the bin log. We have already covered in our theoretical session about binary logs. The slave checks the binary log for these changes and writes them into a relay log. This relay log then writes these changes to the database. So let us see about binary logs once more. So replication is possible because of the binary logs or the bin logs. We will need to understand how the binary log works in order to have control over the replication process and in order to be able to fix any problems that occur. The purpose of this bin log is to record changes made to the tables in the database. So the bin log does not record any queries that do not change data. The bin log contains events that describe these database changes such as table creation, operation, or changes to the table data. It also contains events for statements that potentially could have made changes. For example, you can say a delete statement which matched 0 rows. That is unless row-based login is used. And the binary log also contains information about the execution time for each data statement that updated the data. This binary log is not just a single file, but a set of files that allows for easier database management. So you can remove the older logs without disturbing the newer ones. There is also a binlog index file, which keeps tracks of which binlog files exist. And only one binlog file is the active file, and this active file is the one that is currently being used for data writes. The binlog can then be used for replication, for point in time recovery in backups, and in some limited cases for auditing of data. So this is the binlog event from where you can see what all is happening in the database. I have shown just a simple example of it in here, wherein the log name in this column, the log name, this stands for the binlog file that is being referenced or was used for this statement. And the POS, position, this is the position in the file where the event starts, the first byte of the event. The position is the key in using the binlog to replicate data and when promoting slaves to masters. And next, this event type. This is the type of event. There are about 27 different type of event types, such as format underscore desc, which is in here, stop, query, xid, and many more. Table map, update rows, rotate, many more are there. The server id, the id of the server that created this event. So we will come to know about the server id as we proceed with our practical sessions. The end log position, the ending byte of the event, here it is 123, where this event ends and where the next one begins. Info, which is information about the event. The different information is printed for different events, but you can at least count on the query event to print the statement that it contains, unless you are using row based replication. So this is the MySQL replication basic architecture. In here, this is how the events flow through a replication system from the master to the slaves. So at first what happens, a session on the master accepts a statement from the client and then executes it and then synchronizes with other sessions to ensure that each transaction is executed without conflicting with other changes made by other sessions. And then what happens? Just before the statement finishes this execution, an entry consisting of one or more events is written to the binary log on this master. And after the events have been written, this is step 3, a dump thread is created on the master when a slave IO thread connects. And the dump thread reads the events from the binary log and sends them over to the slave's IO thread. There is one dump thread per connected slave. And next comes the fourth part, which is in the slave part. When the slave IO thread receives this event, it writes to the to the end of the slave's relay log, which you can see in here. And then once in the relay log, a slave SQL thread reads the event from the relay log and then executes the event to apply the changes to the database on the slave. It is also responsible for coordinating with other MySQL threads to ensure changes do not interfere with other activities going on into the MySQL server. So these are some of the basic replication types: master-slave replication, master-master replication, and group replication. So coming to master-slave replication, this was the first replication option for MySQL database, which I already told earlier. It assumes that you have a single master server that accepts both read and writes and one or more read-only slave servers. Data from the master server are asynchronously replicated to the slave servers. It has some advantages like it is very fast and does not impose any restrictions on performance. You can split read and write requests to different servers. For example, all analytics queries can be made on slave nodes. Everything will be having some advantages as well as disadvantages. You need to choose between them and take one. So the disadvantages are, it is not very reliable because of asynchronous replication. It means that some committed data on master transactions may not be available on slave if the master fails. Write requests can hardly be scaled. The only option to scale write requests is to increase compute capacity, which is RAM and CPU of the master node. Failover process is manual in a general case. You should take care of promotion in replica node to master 1. Next is MySQL Master-Master Replication. The Master-Master Replication has been evolved from Master-Slave Replication and solves its major issues. So to compensate the issues of master-slave, MySQL has introduced the Master-Master Replication. This type of replication assumes that you have two or more master nodes that can accept both read and write requests. In master-slave, in the master itself, you can go ahead with read and write, whereas in the slave, you can just go ahead with write option, right? I'm sorry, you can in slave, you can go ahead with read only option. But in here, you both are master nodes, and in both nodes you can go ahead with the read and write requests. In addition, you can have multiple slave nodes for each of your masters. The replication between master nodes is asynchronous. It also has some advantages and disadvantages. The advantages have you have an option to scale write requests not only by increasing the computing capacity of a single master node but via adding additional master nodes. Failover semi-automatic because you have multiple master nodes. The chance that all master nodes fail simultaneously is very low, and if any of the master nodes fail, there is at least one more master node that can handle its request. And the disadvantage is, as I said earlier, it's an asynchronous mode. So due to this asynchronous replication between all master nodes, you can lose some transaction in case one of the master nodes fail. And due to this asynchronous replication itself, we cannot be sure that backups made on each master node contain the same data. Failover is still not fully automated as we saw earlier in case you need to promote a slave node to a master node. Next comes MySQL group replication. This feature is implemented by a MySQL server plugin and provides replication in a completely new way based on distributed state machine architecture. The group replication allows creating fault-tolerant systems with redundancy that guarantees even if some of the server fails, the cluster still will be available. The unique feature of this group replication is that it provides you with built-in automatic recovery and conflict resolution. And how this replication helps you? It removes the need of manual switching in case of failure of one of the servers. It provides the fault tolerance. It allows you to build a system with the ability to change data on a server, on any server, and it provides automatic reconfiguration. It also has some advantages and disadvantages. The advantages being automatic failover. It is synchronous replication in general, so you can be confident that you will not lose any committed data in case of any of the master nodes fail. You can scale both reads and writes by adding new master and slave nodes. It does not impose big performance restrictions because it is enough to have only two master nodes for a full-fledged MySQL cluster. And disadvantages being it is available only for MySQL but not for its forks like MariaDB and Percona. And one group is limited to 9 nodes. So this concludes our topic on MySQL replication theoretical part. So let us jump quickly to the practical session and see how we can proceed with our replication. So this is my master server which I am taking, and this one target as the slave server. So in slave you can see that one instance is running with slave.cnf, and in here I have my.cnf. So what I need to do, I need to take a dump of the master and restore that on slave. So the command is, let me first check what all things are available over here. Let me log in and check it. Show databases. So I do have some databases available over here. I'm using infra show tables. Yes, I have tables also created in here, and this was done in our first lab where we installed MySQL. So now what I need to do, I need to take the backup. So what is the backup utility? Before that, let me go to the directory. I have some databases or some backups over here which we saw how to take the backups during our backup session. And let me take the dump and then the defaults file. So what is the default file? This is the defaults file, and let me give the username, then the password. I can give the password over here, or it will be asking for the password later on. And then since I'm taking a full database backup, so the command should be --all -databases, right? And then let me give --master hyphen data equals to 2. So what is this master hyphen data equals to 2? This suggests that the current binary log position does not apply to the database and a manual intervention is required to apply the bin logs. If this is 1, then it automatically applies the bin log after noting down the bin log position. But a value of 2 is suggested so that if any error occurs during restoration, then the whole instance may get corrupted. Then hyphen quick, then hyphen single transaction. For these you need to refer my MySQL dump backup session where I have mentioned what is hyphen quick used for, what is hyphen single transaction used for. Then hyphen VVV. What is this VVV? This is verbose. This is to get the details of the backup during the run phase. Then hyphen force, and I need to take the backup. Let me give the name as slave.sql. So this is my backup name, and let me fire it. So you can see the backup has been taken. You can see in here like this. Now what I need to do, I need to transfer this backup to my target database. Let me give the password and log in and go to this directory and put slave.sql. So I have transferred that dump to my slave database. Now what I need to do, I need to restore it. I'm here in this database, and first of all I will show you that nothing is present in here. Hyphen u root, then hyphen p password. So you can see nothing is present in here. Now what I need to do, I need to restore it. So what's the command for restore? Let me run it in nohub and then MySQL. Then I need to give the username, which is root, the password, and let me give the socket file. So where is the socket file? This is the socket file. And from where do I need to restore it? From MySQL dump and then this one. So from here I need to restore it, right? And I'm running this so that it runs in the background. So let me just fire it. So currently this is running and it is complete. Now let me log into the database and check whether the files are present or not. So you can see that the database are available, so it has been restored. See, for use for infra database also, which we saw in there, the table infra has been provided. So the restoration is successful. Next, what we need to do, let us go to the master. And in master, let me edit the my.cnf file. So this is my my.cnf file, and in here I do have binlog format equals to mixed and server ID equals to 1. If it is not present, you need to provide this. So it is there, so it's not a big problem in here. Now what I need to do, let me log into the database again and let me see what all users are created. So we have these users created in here. Let me create a replication user in here. So the command is create user, then the username, let me give the name as repl@. From where do I need to give it? From my slave. It should be connecting, right? So this is the one it should be, and then I need to give the password. Let the password be the same as a username. Only this, will that suffice? No, I need to give this user I need to grant privileges to this user to work as a replication user. So what's the grant privilege I need to provide in here? Grant replication slave on star.star to this user and identified by this password. So this is done. So we are good with our master database. Now let us log into the source database. So here we are in our source database, and one more thing let me give in here, flush privileges, so that the changes are effective from now itself. Now in here, first thing what I need to do, I need to edit my CNF file. And in this CNF file, what things I need to give in here? See, the server ID. The server ID should be 2 because master needs to be server ID 1 and slave needs to be server ID 2. Okay. And one more thing I need to give in here. Can you recall it? In master we are using Binarylogs, and in slave what we are using? Relay logs. So I need to give the relay log in here, and let me give this in this path, and the name format should be like this: the host name, then hyphen relay hyphen bin dot index. So this should be it. Now this is done. Now one more thing I need to do in here, I need to take the master log from where it should be applying the logs. So how do I get it? From my this slave, since I gave the command master data equals to 2, that's why in here I'll be getting this one, right? So let me just copy it and let me just paste it in a notepad. And in here some more things I need to do. Master log position is fine, and some more things what I need to give means how will it come to know which is the master host? So I need to give the master host, right? The master host is 172.168.190.15, and I need to give the username also from with which it will be connecting. So the master user needs to be this, which we created in our master server database, and then the password needs to be also the master port. So these are the connectivity details which we need to mention over here. Now let me log into the instance and then fire this command. So this is done. Now I need to do start slave. So this will be starting the slave. Show slave status. With this I can see the slave status, and you can see in here that it is trying to connect. Let us see whether it is able to connect or not. No, it is not able to connect because master and slave have equals MySQL server IDs. These IDs must be different. So what's the blunder I made in here? The blunder is I didn't restart my instance after making the changes effective. So I need to restart my database, my instance, my slave instance. I made changes in my this file, but I didn't restart it. And then let me give the socket file in here, the username, password, and then shutdown. So this is shutting down the database, and it is the instance is shut down. Now let me go to this path, then bin mysqld. Let me fire this command. So this is starting my instance. Now my instance is up. I need to log into my instance and start the slave now and see for any errors. Okay, my slave is running and it took everything from here. So right now my instance is in sync, and you can see in here what all things you need to see. The master host, it is showing in here, master user, master port, the master log file. You can see the master, show master status over here. So this is the bin log file and the position is 6792. You can see the master log file and the master log position. So it is currently in sync. Slave IO running, slave SQL running, these are yes, so it is running. From here you can get the info on your master, of your master. My bad, this one needs to be cat from here. So you can see in here, you can get this information over here also. And if this is a table being created, then from select star from, like that you need to see. Okay, now from here also what will you see? How will you see the slave process for this instance, for this master instance? You can see here that this is the replication user and this is the replication server. means the slave server, and you can see the master has sent all binlog to slave waiting for more updates. Now in here I have these many databases currently running. Let me create one more database and see whether it gets replicated in my slave or not. You can, from slave, you can see in slave these are the databases currently created. So in my master, let me create a database, create database replica. Okay, then another one, create database replicate. Okay, then create database infra experts. Three databases have been created in here. You can see infra experts, replica and replicate. This, if my slave is running and everything is fine, this should be replicating to my slave server, right? So let me see. Infra experts, replica, replicate has been created over here. Now, one more thing what we can see in here is we can create a table, and we can see whether the table is getting created over this slave or not. So let me take this in here. Let me create table replica and keep these as it is, and let me run this create table in my master. And where will I create it? I'll be creating it in replica database. Show tables. So currently this replica table has been created in my master. Let me see whether this got replicated in my target or not. You can see that it got replicated in the target. So I believe till now what all we have seen, it is clear to you. In here we saw about the different replications available, and we also saw the theoretical part, and we saw how to create a master slave replication in MySQL instance. So this concludes our today's session, in which I hope you have learned a bit from here and it might be useful for you. So please do like, share and comment, and let me know if anything else is required from this session, and if you need anything more. Thanks a lot for watching the video. Take care.